Hi everyone, welcome to part 1 of inverse of functions. So we're going to start off by letting f and g be functions such that if f of g of x equals x and g of f of x equals x, then our functions are going to be inverses. So please make sure you fix number 2 if you have it not written like I have it here. So when both of these are true, this is known that they are inverses. Okay, G and F are inverses of each other. And we're going to use the notation of F with a little -1, and we're going to read it as F inverse. Okay, so again, the inverses has, if I have F of inverse of F of X, and it equals X, and then F inverse of F of X equals X, then they're inverses. So basically, if you perform the composition, in either order, you should get X as your answer. If you get X for both of them, then they're inverses. If you do not get X for both of them, then they are not inverses. So if we look at example 1a, it says show that f of x equals 3x plus 2 and g of x equals x minus 2 divided by 3 are inverses of one another. So step 1, we're going to do f of g of x. Okay, so that means I'm going to have f of g. G is that x minus 2 over 3. And anywhere I see an x in f of x, I am going to replace it with x minus 2 divided by 3. So this x right here is going to be replaced. You will no longer have that x there. So I have 3 times x minus 2 divided by 3 plus 2. Then we simplify this. So 3 times that fraction, what happens is the 3's end up canceling out. Cancel, cancel. And then I'm left with x minus 2 plus 2. Well, what happens here is the 2's cancel out, and my final answer is just x. So far we're on the right track. Okay, so now we go ahead and go to step number 2. Step number 2 means we do the same thing, but we switch the order. G goes first, and f of x goes on the inside. So what that looks like is g of 3x plus 2. Anywhere there's an x in g, we're going to replace it with 3x plus 2. So this x right here gets replaced. So that looks like 3x plus 2 minus 2 over 3. The 2's cancel out. That leaves me with 3x over 3. Now we see that the 3's cancel out, and my final answer would be x. So since I did the composition of f of g of x in 1, and the composition of g of f of x in number 2, and I got x as both of the answers, that means that f and g are inverses. So we're going to write that down. Since f of g of x equals x, and g of f of x equals x, f of x and g of x are inverses. And that's it. Okay, let's look at 1b. Is f of x equals 2x minus 8 and g of x equals 1/2 x plus 8 inverses? So we do the same thing. So 1, we're going to do f of g of x. Well, that is the same thing as saying f of 1/2 x plus 8. Anywhere I see an x, I'm going to plug it in with 1/2 x plus 8. So I have 2 times x, so that's the 1/2 x plus 8 minus 8. I multiply it out. So I distribute 2 times 1/2 x is x. 2 times 8 is 16 minus 8. So when I simplify this, I get x plus 8. Since I did not just get x, that means they are not inverses. So since f of g of x does not equal x, g of x and f of x are not inverses. Okay, so again, to check if two functions are inverses, all you're going to do is perform the composition. Now, moving on to the horizontal line test. This is similar to the vertical line test, except it's not checking to see if the graph we're given is a function. The horizontal line test tells us if its inverse is a function. So, same concept. If we draw a horizontal line, okay, and it hits more than one point, then our inverse is not a function. So if I look at this first graph here, I draw a horizontal line like this, okay? My graph hits two spots on, or my line hits two spots on the graph. So this tells us that the inverse is not a function. Okay, looking at our next one, if we draw a horizontal line, no matter where I draw it, it's only hitting one spot. So we know for this one that the inverse is a function. Now, it is possible for our inverse to not be a function like we said, but we're focusing on inverses that are functions, okay? So if a function passes the horizontal line test, it is known to be a one-to-one function. Again, that just means that the inverse is a function, okay? So only one-to-one functions have inverses that are also functions, okay? So it's going to pass the vertical line test and the horizontal line test, so it's one-to-one. Okay, now the last part is just graphing inverse functions. So all we're going to do is we're going to reflect the inverse over the line y equals x, which means basically all we're doing is switching the x and the y and plotting the new points. So I have some steps to help you out if you need them. Okay, first you're going to label the given points. So let's start off by doing that. So I have, let's see, we go over 1, 2, 3, 4, -4, we go down 2. So this point right here is -4, -2. Then I have the point -2, +1. And then I have the point +2, 3. All we're going to do is switch those x and y points to get our new values. So instead of -4, -2, our new point is going to be -2, -4. So I'm going to go ahead and plot that. -2, -4 is right here. And then I have the point -2, 1. So now I'm going to plot 1, -2. And I'm going to go ahead and connect the two dots that I have. My last point is 2, 3. I switch it to 3, 2. So 3, 2. Looks like that. And if you look, if we were to fold it over that blue line, y equals x, then they would be a mirror image of each other. So again, this blue line is y equals x. So we got one more. Again, the blue line is y equals x. We're going to start by labeling the points that were given. So this first one is -2, -4. Oh, -4, -2. Or I mean -2, -4. Sorry, it's writing them backwards. I have 1, -3. I have 3, -1. And lastly, I have 4, negative 2. So I am just going to plot these points, okay, by switching the x and the y. So we have negative 4, negative 2, negative 4, negative 2 is right here. I would have negative 3, 1, negative 3, 1. Is this point right here? Oh, I'm sorry, that's not it. Negative 3, 1, that's this point up here. I'm writing the wrong points. There we go. Then I have negative 2, 4. Oh, sorry, we want to make sure we go in order, so that means I would go to this point, which would be negative 1, 3. Negative 1, 3. There we go. And lastly, we're going to have negative 2, positive 4. Negative 2, positive 4. Okay, so if we look at that, if we were to fold it over that line y equals x, everything on the left would match everything on the right. So that's how we would do inverses of graphs. So if you have any questions, please write them down and make sure you ask your teacher. And have a great day.